Today I'll be showing you how you can do integration by parts and go for a few examples. So first we have x lots of e to the x. So when you do integration by parts, here's the formula for it. What we gotta do is choose what is gonna be the u and what is gonna be dv by dx. So in this scenario, we have x and e to the x. Now, for choosing the u, what are we going to do to u? We're going to differentiate it. And if we differentiate e to the x, we're still going to get e to the x. So that doesn't really help. But if we differentiate x, then we're going to get 1. Now that seems more helpful. So let's just go about with this. Choose u as x and dv by dx as e to the x. Now differentiating u, we get du by dx is equal to 1. V is obviously still going to be e to the x. Now we can just put this in our formula up here, giving us uv, which is x e to the x minus the integral of v, which is e to the x multiplied by du by dx, 1 times e to the x, which is just e to the x. So now we can just find the answer to this very quickly. It's x e to the x minus the integral of e to the x, which is just e to the x. And don't forget your plus c, and that's our answer for the first one. Here's our next integral, x cos x. So again, if we chose u as cos x, we're going to get minus sin x when we differentiate it, which is still not helpful. So choosing u as x again seems like the best way to go. And dv by dx is cos x. That will mean v is going to be sin x, as sin x differentiates to cos x. Now du by dx again is just going to be equal to 1. So now we can put this in our formula. So uv x times sin x minus the integral of du by dx multiplied by v, v. So we get 1 times sin x dx. Now we're just going to get this equal to x sine x minus the integral of sine x, which is minus cos x. So we're going to get plus cos x, as the two minuses will combine to make a plus. And then we have plus c. Okay, for our next one, we have the integral of ln of x. Now, you may have seen this before and been like, okay, let's just skip this as we can't integrate ln of x. However, using integration by parts, we can integrate it. But you may wonder, how can you do integration by parts? There's no two things being multiplied by each other. Well, if you think about it, ln of x is the same as 1 times ln of x. So if we choose, well, we don't have much of a choice because we can't choose dv by dx as ln of x because we're trying to integrate that. So it'd be pointless choosing it. So we have to choose u as ln of x. That's going to mean du by dx is going to be 1 over x, as ln x differentiates to 1 over x. dv by dx is going to be 1. So v is going to be x. Now putting this into our integration by parts formula, we're going to get x ln of x minus the integral of du by dx, which is 1 over x multiplied by v. Now the x's are going to cancel, so we're left with x ln x minus the integral of 1, which is just x ln x minus x plus c, and that's the integral of ln x. Here's our last integral for this video. It's e to the x multiplied by sin x. Now for this one, neither of them is going to give something much easier if you differentiate, neither e to the x or sin x. So it doesn't matter what we choose in this case. So we'll just choose u as sin x and dv by dx as e to the x. So that means v is going to be e to the x. Differentiating sin x, we're going to get cos x. Now we can put this into our integration by parts formula. So we get sin x e to the x minus the integral of v which is e to the x, multiplied by du by dx, e to the x cos x. And this looks like we've just done nothing. However, we can continue doing integration by parts on this part. So now we have sine x e to the x minus the integral of e to the x cos x. So integral on itself, again, we can label u as cos x, dv by dx as e to the x, so v will be e to the x, du by dx is going to be minus sine of x. Now we just sub this into our formula. We're going to get cos x e to the x minus the integral of minus sine x e to the x. So we're going to get sine x e to the x minus the integral of e to the x cos x, which is this cos x e to the x minus the integral, actually no, plus, because we have two minuses combining to make a plus, sine x e to the x. Now we can, if we go down, we can simplify this. So we have the integral of e to the x sine x dx is equal to, this just our original integral, sine x e to the x minus cos x e to the x minus the integral of sine x e to the x. Now, if we let this integral equal I, if we notice, we have the same integral on both sides of the equation. So if we replace the integral of e to the x sine x with I, we're going to get I is equal to sine x e to the x minus cos x e to the x minus I. Now, we can just treat this like normal algebra. We get 2i, if we add on I to both sides, is equal to sine x e to the x minus cos x e to the x. Dividing both sides by 2, we're going to get I is equal to a half lots of sine x e to the x minus cos x e to the x. And that's our final answer. So I is just equal to the integral of e to the x sine x. And this is equal to a half lots of, let's take e to the x out of as a factor as well, sine x minus cos x. And as we're integrating with no limits, we're going to have plus c. And that's our final answer. I hope you learned something from this video.